Hello and welcome back. In this video we are going to go over 2019 Free Response Question 3, Part A. So in this question we are told that we have a continuous function f that is defined over this interval, and the figure below shows a portion of the graph consisting of two line segments and a quarter of a circle. The circle is centered at 5, 3. It is known, and this is important, that we have a point 3, 3 minus square root of 5 on the graph of f. And in part A, we are asked if the definite integral from negative 6 to 5 of f of x equals 7, find the value of the definite integral from negative 6 to negative 2. So what I like to do, because I taught geometry for a long time, just to give you a visual, is we know the definite integral from negative 6 to 5 is 7, and then we're asked to find the definite integral from negative 6 to negative 2. So we're finding this piece right here. This is what we're trying to find. Let me get another color. And then we also have this integral here, this definite integral, and notice this graph goes from negative 2 up to 5. So what does that mean? I could say that, I could set up an equation. I could say the definite integral from negative 6 to negative 2 of f of x dx plus we have the definite integral from negative 2 to 5 of f of x dx is equal to the length of everything, so the definite integral negative 6 to 5 of f of x dx. And again, what we're looking for is this definite integral here. We're going to use the graph, so I'm just going to put a little squiggly around this. We're going to use the graph to estimate the definite integral from negative 2 to 5, and then we were given the definite integral from negative 6 to 5 is 7. That's kind of how we're going to go about it. So hopefully you can see it, and again, I taught geometry for years, 12 years, 13 years, so I like to set it up this way just so you can see the equation I'm going to set up. Alright, so let's look at the graph. We're going to try and figure out definite integral from negative 2 to 5 of f of x dx. So we're going to be doing an accumulation. So imagine that we don't want to find the area between the curve and the x-axis, but imagine that we can cancel and we can move things around so we can move quickly. Notice that this area from negative 2 to 1 should cancel with the area from negative 1 to 0. Then if I look over here from 0 to, say, a half, this little area here should cancel with this one. Again, area above is positive, area below is negative. So then what happens is I end up with this cute little trapezoid. I'm not sure if you can see it. And if I get a little creative, I can square it off. I can see this is 1. And if I take this little region right here, I can rotate it here. And that would mean I would end up with 2. I would end up with 1 plus 1, which would mean I would have an area of 2 for this region right here. I don't know if you can see it, or you could find the area of the trapezoid. So I would say, okay, I'm starting with 2, and then I would have to figure out the area under the curve, or between the curve and the x-axis here. Now remember they told us that we had a circle. I'm not going to draw the whole circle, or I guess I will. See the whole circle, it's there. It's actually only a quarter of a circle. So what I'm going to do is I'm going to find the area of the whole square and subtract the area of, or I'm going to subtract a quarter of a circle. So I'm going to have plus, and what I'm going to do is I'm going to find the area of the square. It's a 3 by 3, so my area of my square is 9. And then what I'm going to do is I'm going to subtract 1/4 of my circle. So I would have 1/4 pi r squared, 1/4 pi r squared, and your radius is 3. So I get 1/4 times pi times 3 squared. This would mean that I end up getting 2 plus 9 minus 9/4. Oh, what if I forgot the pi? 9 pi over 4. So far so good. You can combine like terms if you want. You can leave it like this, whatever you desire. This would end up being 11 minus 9 pi over 4. So all I did was combine the 9 and the 2. You don't have to do that. Now what I'm going to do is I'm going to go back up here and I'm going to leave this as the definite integral from -6 to -2 of f of x dx plus what I just found. So what I just found, which was 11 minus 9 pi over 4, and put that equal to the given value, which we knew was 7. And I'm just going to solve for this definite integral. So the definite integral from -6 to -2 of f of x dx is equal to 7 minus this whole quantity. Make sure you leave it in parentheses or some kind of grouping symbols. So you have 11 minus 9 pi over 4. And I would say that's our answer. We could simplify if we want. And let's see how we did. So again, this would be our answer. We don't have to simplify. We check out the rubric. If you set up an equation, you get a point of all your definite integrals, so using your properties of integrals. If you use the graph, and you get this answer right here, it doesn't matter how simplified it is, you get a point. So we use the curve, we found the area, and then if you find the total answer, you get another point. Now notice they simplified. We did not, but hopefully you're happy with our answer and you don't have any questions. If you do, just send me an email. I hope you enjoyed.